Well, hello, and here we go. We've got another exciting AP problem for you to attack. So, as you can see, it's just one question tonight, and this is a fairly recent question. This is from our 2011 exam, question number 2. So I do want to make a note that it is calculator active. So grab your calculator, don't try to do this without one. And the best thing for you to do is to not cheat yourself. Pause this video, try it, and then go through my solutions. If we're not getting a 9 out of 9 on this, we're in a little bit of trouble. This should be something we can attack. If you're 1 or 2 points away making a little mistake, here and there, that's okay. We've got till May to fix it. But we shouldn't be just stuck on any of these. You should have something down for everything. So pause it, try it on your own, and then compare with mine. All right, part A. Use the data in the table to approximate the rate at which the temperature of T is changing at time T equals 3.5. Show computations that lead to your answer. Well, the key calculus word in the sentence to me is that 4-letter word, rate, which is telling me to look at the derivative. And where should you look at the derivative? Well, at T equals 3.5. So, you'll notice 3.5 falls between 2 and 5. So those are the 2 points I'm going to use. So I'm going to say h of 5 minus h of 2 all over 5 minus 2. So that gets me 52 minus 60 all over 3. That looks like a negative 8/3. So this answer itself was pretty generic. Again, hopefully that's at one point everybody can get, and that was worth +1 out of our 9 points. Part B. Using correct units, explain the meaning of this integral in the context of the problem. Then, use a trapezoidal sum with 4 subintervals indicated by the table to estimate that value. So, hopefully you caught this 1 over 10. When you see that number out front, what word has to pop in your head? What formula has that 1 over b minus a in front of it? So hopefully you've decided to say the integral from 1 to 10 of 0 to 10 of h of t dt indicates the average temperature in degrees. So there I am talking about my units. And you can say during the first 10 minutes, or from t equals 0 to t equals 10 minutes. But hopefully that does it, and that should be pretty straightforward, I would assume. So that expression itself is going to get us 1 point. So again, 2 pretty basic points on this exam so far. Now I need to get that trapezoidal Riemann sum, and they told me with 4 subintervals. So I'm going to break it up real nice. 1, 2, 3, 4 subintervals. Now, let's just talk about that formula for a trapezoid. You should have 1/2 height, height 1 plus height 2. So I'm going 1/2. The base on my first one is different than my second one, so I have to do each one separately, but I can pull the 1/2 out of everything. So my base, remember base is the bottom, the x values, h is the height, the second one. So my base is 2, and the height of my trapezoid is going to be 66 plus 60, plus my next one has a base of 3, and I should be using 60 plus 52, plus, that's a base of 4, 52 plus 44, and a base of 1, 44 plus 43. Now, the one thing that is missing from my answer is that if I look at that original question, not only did they want that integral from 0 to 10, they wanted 1/10. They wanted the average, and that was by far the most missed thing. You also have to have a 1/10 out front of this integral for the average of that. Now, certainly this is calculator active. I'm going to grab my calculator and do the jargon inside there. And I end up with 1059, and if I multiply that by my 1/20th, a final answer of 52.95. So again, the biggest mistake was missing that it still wanted to include that 1/10 in there. All right, part C. Evaluate the integral from 0 to 10 of h prime of t dt. Then, using correct units, explain the meaning in the context of the problem. Well, basically I said to myself, what the heck is h prime of t? I don't have anything about h prime of t. All I have is this function h. And here's where that first fundamental theorem of calculus comes in. If you integrate from 0 to 10 of h prime of t dt, who do you get? Well, the integral of h prime is h, and you get upper minus lower. H of 10 minus h of 0. Now I can use my table to evaluate that. A couple people I notice keep putting this 1 over 10 in the problem. Nowhere is there a 1 over 10 involved. This is not average anymore. When you integrate h prime, you should get h, plug in the upper, minus the lower. And like I said, we'll just quickly grab these values from the table. H of 10 looks like 43. And h of 0 looks like 66. So if I do my math there, I should get negative 23. Now I need to describe what that means in the context of the problem. And again, I'm kind of ignoring this, and I'm talking about what I just found. Well, if I evaluate h of 10, I get 45 or 43 degrees Celsius minus 66 degrees Celsius. Basically, what I'm describing is that the temperature of the tea, I believe this question was about, dropped (23 degrees Celsius from t equals 0 to t equals 10, or you could say in the first 10 minutes. Okay, and again, the reason I'm saying dropped, I just want to be clear, is because I got a negative value here, so I know the temperature went down, so the temperature of the tea dropped. Make sure you don't say it dropped a negative amount, then you kind of have that double negative going on. All right, last part. Part D. At time t equals 0, biscuits with temperature 100 degrees were removed from an oven. Let's just stop there. Did you catch the first fundamental, that initial condition? The temperature of the biscuits at time t is modeled by this differentiable function b prime of t. Using the models, at time t equals 10, how much cooler are the biscuits than the tea? So first of all, what is the question asking for? Let's read that again. How much cooler are the biscuits than the tea? So if I want to know how cool they are, basically I need to compare their temperatures. All right, I'm comparing the temperature of the biscuits at 10 and the temperature of the tea at 10. Now one of those you should know. This table, remember, represents the tea. So I know at 10, the tea had a temperature of 43 degrees Celsius. So I have to use this given equation b prime to write an equation for b. Well, if you have b prime and you want b, obviously you need to set up an integral. Is there an initial condition? I hope so. I should be writing that b of t is equal to 100 degrees, my initial condition, plus that 100 degrees happened when t equals 0, and I want the answer at t equals 10, and I would integrate b prime of t. So I'm going to grab my calculator, and I get b of 10 to equal 34.183, and I need to subtract my 43 degrees to find the difference in the temperature. And I would say there's a difference when I subtract that of 8.817 degrees Celsius. And I would definitely say that the biscuits are cooler than the tea.